So last video you guys learned about second law, right? Okay, see now let's see, there is one more topic what you guys need to know, that is what we call as impulse. See, impulse is basically how much ever force you have for a unit amount of time. Okay, so force into time gives you impulse. See, for example, let's say you are catching a cricket ball. So what you do, you take the ball, you catch the ball and you go along with the same direction. See, I've been giving you this example because this is most commonly used example and it's very easy to understand also, correct? So you catch the ball and you give time so that the ball stops. See, here you're increasing the time, correct? So the force, whatever it's actually acting on the hand, that becomes smaller. Okay, so basically impulse. So impulse is basically if you have a large force acting on a body in very small amount of time, so that basically is impulse. Like, say you hit something, that's impulse. Okay, so impulse is basically that. Okay, understood? That's all. Impulse is very easy. Now we'll just go through all the problems we'll do based on whatever formulas you have learned. That's basically force equals m into a, m into acceleration. Okay, so all these things. Alright, so let's start with question number 1. So question number 1 says a constant retarding force of 50 Newton is applied to a body of mass 20 kilos moving initially with a speed of 15 meter per second. How long does the body take to stop? Understood? So this is basically the question. See, you have a retarding force of 50 Newton. So see, force is a vector, correct? So your force becomes minus 50 Newton. So F equals minus 50 Newton. M is equal to 20 kg. Now, initial velocity is 15, correct? But look at this. So what they're actually trying to ask you is the body starts with 15 meter per second and stops, correct? When it stops, what is the final velocity? 0. So V becomes 0. So you have F, M, U, V, correct? See, now we need to find the acceleration. Acceleration we can easily find out. So use Newton's second law. F is equal to m into a. So minus 50 is equal to 20 into a. You'll get a value as minus 2.5 meter per second square. Correct? See, why acceleration is negative? Because it's a retardation, correct? Right? Okay. Now, see, you know acceleration, you know final velocity, you know initial velocity. Which Newton's law or the equation of motion will you use to find the value of t? Remember, think about it. If you think about it, V, U, A is given. You need to find t. Which formula? V is equal to U plus AT. Right? So if you substitute that, so V is 0, U is 15, A is minus 2.5 and time you need to calculate. So if you substitute, T is equal to minus U by A. So that's a minus 15 by minus 2.5, which gives you 6 seconds. Okay. So a body of 20 kilos which has a retardation of 50 newtons takes 6 seconds to stop. Understood? Fine. Let's go to the next one. So next one says a body of mass 5 kg is acted upon by two perpendicular forces 8 Newton and 6 Newton. Give the magnitude and direction of the acceleration of the body. Okay? Acceleration of the body. Okay, now see, look at this. Look at the figure. So you have a 6 Newton and 8 Newton force. Correct? 6 Newton and 8 Newton. So this is the body. See here, 8 Newton and 6 Newton. So see, in this case, what we have is, see, what is the mass of the body? Mass of the body is 5 kg, correct? That is fine. Now, if you look at the picture or if you look at the graph, whatever we have, so you have one 8 Newton and one you have minus 6 Newton. See, why? Because the body, for the body, the force is acting downwards. So you will get a minus 6 Newton. Okay. Okay, minus 6 Newton. Now, see, theta, let theta be the angle of the resultant force. Okay, theta be the angle. Now, theta you can calculate using trigonometric function. Okay, see, I'll just tell you the basis of trigonometric function here. What we use is we have a trigonometric function called as tan of an angle theta. So we use this tan theta to find out. Okay, so if you use tan theta, so you'll get tan theta is equal to minus of 6 by 8. Okay, or theta gives you tan inverse of minus 6 by 8, which gives you almost equal to 37 degrees. Okay, but here, see, you have a negative sign, correct? Negative, so negative 37 degree. Now, what does that negative sign indicate? See, that indicates, see, theta is in clockwise direction, correct? It's in clockwise direction. If you guys remember, whatever angle we actually calculate, they're all in anti-clockwise direction, correct? So, anti-clockwise direction angle, that's positive. Clockwise direction angle is negative. Okay, so in this case, since we are looking at in the negative side or the clockwise direction, you'll get the negative angle. Okay, fine. Alright, so now coming to force. So force is equal to mass into acceleration, right? See, in this case, the force I need to calculate, right? See, if you look at this 6 and 8, so if you look at the figure here, see 6, 8. Now, what is the hypotenuse? 10. Correct? 6, 8 and 10, Pythagorean triplets. So, acceleration becomes 10 divided by 5. That is 2 meter per second square. Okay, so you got the magnitude and direction.